The following question reads that H and I are isomers with the molecular formula C2H4 and O2. So there are two carbons, four hydrogens, and two oxygens. And the infrared spectra of isomers H and I are shown. So the infrared spectrum is given for both H and for I as well. So these are given. And the next part of the question reads that you need to identify the bonds responsible for the principal peaks above 1500 per centimeter in each spectrum. So the wave number 1500 and above. You need to identify the bonds in spectrum H and also in spectrum I. So let's go back and have a look at the spectrum, infrared spectrum of H first. So if you have a look over here, and remember above 1500. So there's a very strong absorption over here. So let's mark that. That's around 1700. So around 1700, a pretty strong absorption at 1700, and there's another relatively strong absorption around this 3000. But this one is a very broad. It's a very broad absorption. So this one is very broad. Now let's open up the infrared spectrum table in the data booklet and figure out what these two absorptions refer to, which bonds would be vibrating and absorbing frequencies at these particular wave numbers. Now I've opened the data booklet and let's have a look. We had a strong absorption at around 1700, and you would notice that there's a very unique absorption of this particular bond, C double bond O, at around 1700. So I'm not really sure which C double bond O we're talking about, whether it's amides or ketones or carboxylic acids or esters, because they all have overlapping range, but there's a strong absorption at 1700 for C double bond O. And the other absorption that I had was a very broad one. So if you look at the appearance of the peak, you would notice that there's a strong and very broad absorption at around 3000. We had an absorption around 3000, and this is the OH bond in carboxylic acid. So there was this particular absorption. So I'm suspecting that my molecule is a carboxylic acid because I have a strong absorption, a broad absorption, a very broad absorption for an OH in carboxylic acid, and carboxylic acid group also contains a C double bond O. So I also had an absorption at around 1700. So going back to my infrared spectrum, this is the broad absorption because of the OH bond. This is the strong absorption around 1700 because of the C double bond O. So my hunch is that this molecule over here must be a carboxylic acid. The H must be a carboxylic acid. So there are two carbon atoms. There's going to be double bond O and an OH bond, and there would be three hydrogens attached to it. So this is going to be H. Now I'm going to see what I is. If you look at I over here, I also has a very strong absorption at this 1700 range. So that means there is a C double bond O present. But it also has this sharp absorption, not a broad one, which means you can rule out carboxylic acid, not a broad absorption, but a very sharp absorption around 3000. Now, I know that my molecule is C4. Both of them are isomers of this molecule over here. So what I can do is I can come up with a few isomers that are not carboxylic acids. One is I can have double bond O on one side and H, and on the other side I can have an OH group. So that could be one isomer. One isomer could be an ester. So I can have an ester, C double bond O and single O, and there would be C with CH3. So this is also C4H8O2. So these two molecules are not carboxylic acids. So let's try and figure out which of the two molecules could this infrared spectrum relate to. Now, if you look at the mass spectrum table, I've already ruled out carboxylic acid because there's no strong and very broad absorption. There's a very sharp absorption around 3000. I can also rule out OH altogether because all these OH bonds they have a strong and sharp absorption at around above 3000. So our absorption is at around 3000. So I'm going to look for and it's not a very strong absorption. It's a relatively sharp absorption. We can rule out amides and amines because there is no nitrogen in a molecular formula. You're left with CH bonds. CH bonds they also have absorptions at around 3000. So I can think of CH bonds as having absorptions at around 3000. So carboxylic acid is ruled out. Amides are already by default ruled out. You have alcohols, and I've ruled out alcohols because their absorptions are well above 3000, not at 3000. They are around 3200 or starting at 3500, not at 3000. So the only option left for me is the CH bond. That's the only one that's still coming within that range, and that is part of my molecule. So going back to my spectrum, so the spectrum of I over here, this absorption at 3000 must be a CH bond somewhere. And there are plenty of CH bonds in both of these molecules. I'm going to get rid of this OH, this particular OH isomer, because OH had absorptions at above 3000 and there is no absorption. There's a missing absorption. So I'm going to rule this out. So there's only one isomer that is left that is still in contention, and that is this one. So you have a C double bond O. There's a strong absorption at around 1600, and you have all these CH bonds. So CH bonds would be absorbing frequencies at around 3000. And if you look at the mass spectrum, our isomer also has C single O, and there's a strong absorption around 1000 to 1300. So let's have a look at our spectrum again, and you would notice that there is actually a strong absorption around. I would guess this is 1200. So there is a strong absorption. There's the C single O that would be bending or rotating or contracting, stretching, and absorbing frequencies. So this molecule looks a perfect candidate for what I is. It fits the molecular formula, it also fits the infrared spectrum, and contains all the bonds that are present in the infrared spectrum as well. So here in the next part, I was supposed to identify the bonds responsible for the peaks. So spectrum H, we've already recognized these peaks, 1700, 3000. I've listed the bonds that I've identified according to the data booklet. And in the other spectrum, there were absorptions at 1750 and 3000, and I have listed the bonds over here. And in the last part, I need to name H and I. So I've already figured out what H and I are. So let me redraw them. H was ethanoic acid, so this is ethanoic acid over here. Whereas I is going to be, if you look at this molecule, it's going to be methyl ethanoate. So let's write down their names. One is ethanoic acid, and the other one is methyl methanoate.